Hello everyone. So after a long time, I'm back today with a new problem, and while doing this problem, I enjoyed it very much. So I thought that I may share it with you all. So here is we have the problem is plus q charges are placed on the vertex of a regular pentagon. This is the pentagon and plus q charges are placed on the vertex. Okay, so there are 5 plus q charges. Determine electric field at the center. So here is the center. Okay, so we have to determine the electric field for all these charges in the acting in the center. Okay, so how can we do that? So let's think that this is the net electric field for all these charges, and let's break it in two parts, two components. One is Ex, which is along x direction, and another is Ey, which is along y direction. So now what is Ex? So Ex here is the x component of E, which is electric field. So I am denoting electric field as E vector, so it's x component, so E cos theta. Okay, so and actually this is not E cos theta, this is the summation of all the angles. Here are 5 angles, and for each of angle, let me show you. If let us say that this is x direction, this is y direction, let us say, so if this is resultant E, so we have this, if this is theta, then this is the E cos theta. This, the component of E vector along x direction is E cos theta, and the component of E vector along the y direction is E sin theta. So here we are. So these things happen like this, and in this scenario there are 5 angles. So this is one angle, let us consider, and then after, in this point, let us think that we can imagine a pentagon here. So if imagine this scenario at this point, then again in this point, this point, this point, this point. So there are 5 angles. So the angles of this cos theta will also be added. So now what we can do is that this E will also this E will be still, because this is a constant, this is a constant, but this angle will be added. So I can write here, so Ex will be the addition of all the components along x direction. So that will be, let's say, from k is equal to 0 to 5, here this will be k theta. Let me write in a proper fashion. This is k is equal to 0 to 5 E cos k theta. I hope I could make you understand. So this is this, and Ey, the all the summation of the y components will be like this: E sin k theta. So now let's move forward. So we know that summation of from k0 to kn, summation of e to the power I kx is, well, this will be 1 minus e to the power I nx by 1 minus e to the power I x. Now how is this? How am I getting this? So this is actually a GP series, and the sum of a GP, this is a GP series, and the sum of it is this. The sum of GP series actually is, let us say that sum is S. So S is equal to, it is A 1 minus r to the power n by 1 minus r to the power n, where A is the first term and r is the common ratio, n is the n is the number of terms, and so this is the formula of sum of GP series. Now after this we can write this. How? Let us say the first term is k is equal to 0, so this is 0, so e to the 0 is 1, so this is same as before, and 1 minus e to the power ix is the actual common ratio, so e to the ix to the power n, so that is the thing here, and so the here is 1 minus ix in the denominator. So let us continue. I can write this as one okay, I can write this as e to the power I nx. Well, let us write this as theta, yeah, because I have theta here. I'm sorry, this is theta, these are all thetas. So e to the I n theta by 2 by e to the I theta by 2, and here is a trick. So I took a common of this from this, so I have to make 1 here, so this will be minus I theta by 2 and minus e to the I n theta by 2. So if I multiply this, I will get this, and the same as before, minus I theta by 2 minus e to the I theta by 2. It's same as in the denominator and numerator everywhere. If I do this, if I multiply this, I'll get this line. So I can write e to the I n minus 1 theta by 2 from this. Okay, so the powers will minus, and this will, here is a trick. Okay, I am telling you a trick here. There are two rules, there are two formulas. One is Euler's formula. This will come in handy later. That is e to the power ix is equal to cos x plus I sin x. Okay, and another thing is which I will take here, that is sin x is equal to, I can get this from this formula itself, that is sin x is equal to e to the power ix minus e to the power minus ix by 2I. So you can understand that if I take a minus common in numerator and denominator here, then this will turn around, this will be plus, this will be minus, so this will be plus and this will be minus. So, and if I divide the numerator and denominator both by 2I, and that will be like I mean, let's see. Okay, let's do that. I took a minus here and a minus here, and the next line it will be I n theta by 2 minus minus I n theta by 2 by e to the I n. Okay, and here it will be e to the I theta by 2 minus e to the I theta by 2. Okay. So this, now let's see what we got here, and then I am dividing it with 2i in both cases, so this will cancel out. So I can just write this and the value will be same, but now I have this format, so I can use this in this region. I can use this formula. So I write e to the I n minus 1 theta by 2, and this, that will be sine in the sine n theta by 2 by sine theta by 2. Okay, so here is x, and same acts as n theta by 2, or here theta by 2, so sine, this is the thing. And let's move forward. So let's write that line once again. This was the line originally, it was I k theta, and now we get e to the power I n minus 1 theta by 2 sine n theta by 2 and sine by sine theta by 2. So let's okay, so I can write this as cos I k theta plus I sine k theta, and this will be, I can write this is from the Euler's formula I told before, and this is also Euler's formula, e to the power cos n minus 1 by 2 theta plus I sine n minus 1 by 2 theta, and multiplied by, this will be multiplied by this thing, sine n theta by 2 by sine theta by 2. So that's it. Now, so the real part of this is the real part, and I, we know that I is an imaginary part. I where is if there is I, that is the imaginary part, because I is equal to root over minus 1, and this is a imaginary term, so anything multiplied by this will be imaginary, but this is okay. This is cos k theta. Yeah, so the real part of will be, we can write directly, so that will be this part will be the real part, and here it will be this. Okay, so n minus 1 by 2 theta multiplied by sine n theta by 2 by sine theta by 2, and so we can write that Ex actually is So Ex will be 1 second. Yeah, Ex will be the real part of this, so that will be E into the cos k theta, yeah, and summation over that k is equal to 0 to n, and that means, because yeah, it was just that k is equal to 5 actually, cos e into cos k theta, and that is exactly this cos n minus 1 by 2 theta sine n theta by sine theta by 2, and Ey will be k summation over k 0 to 5. Now here n will be equal to 5 maximum, so that's I'm coming there to that later. E sine k theta. Why? You can ask me why, because okay, there is I and here is i's, so when I write, okay, I didn't write the imaginary part, let me first write that. So the imaginary part of k is 0 to n, I sine, yeah, I can directly write that the imaginary part of okay, let's elaborate a bit. I k theta is equal to k is equal to 0 to n, I sine k theta is equal to, this will be equal to I sine n minus 1 by 2 theta into sine n theta by 2. Wow, okay, sine theta by 2. So here I have a I and here an I, here is an I, so I can just cancel them and the rest will be same. So then again I write here Ey is k 0 to n, that is 5 actually, okay, n is equal to 5, E sine k theta, so that is n minus 1 by 2 theta sine n theta by 2 by sine theta by 2. So here I am, 1 second, let me fix my camera. Yeah, here I am. Yeah, so as it is a pentagon, theta will be equal to 2 pi by 5. So, and we know that n is equal to 5. So let's calculate. Ex is equal to, okay, this will be equal to, there will be an E here multiplied and another E here, this E will be here, still here, so here it will be, this E will be common, it will just be there as a constant, and let's play cos n minus 1, so 4 by 2 into theta, that is 2 pi by 5, and sine 5 into 2 pi by 5, yes, into 1 by 2 by sine 2 pi by 5 into 1 by 2. So here I have this will cancel out, these will cancel out, and I have e into cos 4 by 5 pi sine theta by sine pi by 5. So here is a sine theta. Okay, so sine theta, we know that sine theta is equal to 0, so this will all together be 0. And let's move forward. In the same way, Ey will calculate Ey, and there will be E is constant, and sine, 1 second, E sine n minus 1 by 2, sine n minus 1 by 2 into sine n theta into sine n theta by 2, n theta by 2 by sine theta by 2. So here we know that theta is equal to 2 pi by 5 and n is equal to 5. Let's calculate Ey. E into 4 by 2, sine 4 by 2 into 2 pi by 5 here, and sine 5 into 1 by 2 into 2 pi by 5 by sine 1 by 2 into 2 pi by 5. Here many things will cancel out. First these, and then these, and these, and these two. Okay, so I have here e sine 4 by 5 pi sine, again I have a sine pi, and by sine pi by 5. So I again have a sine pi, and that is again 0. So I can conclude that hence at the center electric field will be 0. And the thing is, we found and calculated that Ex, all the sum of the components of at the x direction and all the sum of the components at the y direction are altogether 0. So the total electric field at the center will be 0. So that's it for today. I hope you enjoyed this maths. Yeah, it's I think this is very interesting, and if you have any questions or any queries, please comment below. If you like my video and you want more videos like this, and then please subscribe to my channel and like, share. That's all. Let's see you with another video next time. Goodbye.